So this example, much more similar to example 1 than to example 2. We have chlorobenzene, which is C6H5Cl, and it's used in the production of chemicals such as aspirin and some dyes. We have 45.6 grams of benzene, and benzene is C6H6. That reacts to produce 63.7 grams of chlorobenzene, which is what we actually make, so we'll set it off to the side for now. Calculate the percentage yield. We know we've taken 45.6 grams of benzene. We're going to assume that it is the limiting reagent because that's all the information we have, and we need to determine the percentage yield. First thing we need to do is determine the number of moles of benzene, and I'll put the chemical formula for it. First thing we need is the molar mass. Benzene is made up of 6 carbons. Looking up the mass of carbon in the periodic table, 12.011 grams per mole. Works out to 72.066. We also have 6 hydrogens in this compound. Each hydrogen weighs 1.008. Multiplies out to 6.048. Totaling that up gives us 78.114 grams per mole for the molar mass of benzene. Now that we have molar mass, we can calculate the number of moles of benzene that we used. That is the mass, 45.6 grams, divided by the molar mass of 78.114 grams per mole, which works out to 0.58376 moles of benzene. Second step, like with any stoichiometry equation, now that we know how many moles of benzene we used, we need to determine the number of moles of chlorobenzene that we should have created. We know that we used 0.58376 moles of benzene. We're going to multiply that by the mole ratios from the chemical equation. Benzene, coefficient of 1. Chlorobenzene also has a coefficient of 1, so that will make the math a little bit easier. Always putting the substance that we're trying to find on top. Which means that in theory, we should have created 0.58376 moles of chlorobenzene. Now that we know how many moles of chlorobenzene we should have created, we can go and we can determine the mass of chlorobenzene that we should have created. To do that, we need the molar mass. Chlorobenzene being made up of 6 carbons, each one weighing 12.011 grams per mole. So 72.066 again here. 5 hydrogens this time, each one weighing 1.008, which gives us 5.04. And there is a single chlorine in that molecule, and chlorine weighs 35.453 grams per mole. And that totals up to 112.559 grams per mole. So again, since we are trying to find the mass of chlorobenzene, looking at the mole conversion chart, the mass is always the number of moles. So 0.58376 multiplied by the molar mass, 112.559, means that we should have created 65.7 grams of chlorobenzene. Last step here is going to the percentage yield. Actual divided by theoretical multiplied by 100. We actually made, this was given in the question, actually made 63.7 grams. Theoretically should have made 65.7. Working that out, and this will be 3 sig figs, 97.0%.